describe you best? Super team member, one of our besties. He works for MetaBlack, so he's the guy who can tell you everything about NFTs. Also, he used to be a teacher at Turbine, so he's also super good in teaching, obviously. And yeah, I just give the mic up to Leo. Leo, thanks so much for being here. And yeah, please welcome him.
Thank you very much, guys. So yeah, excited to be here. So I'll say, wait, let's just jump in. So what do I do when I want to actually code on Solana, but I don't want to actually use Rust? That's what we're going to talk about today. Starting your journey on Solana. So before starting, this is me. I'm a Dijonate. I'm that monkey there. And I'm a community developer at Metaplex, so we are the standard for digital assets. We do NFTs, fungible token, pretty much whatever you need. And I'm a former teacher in DevRel at Turbine that is, in my opinion, one of the best institutes on Solana to learn smart contract development. So you can see I have my LinkedIn. I don't use it because I'm a Dijon. I have my Twitter there, my Telegram. So if you need anything else, you can just contact me there. Cool. So how do you code on Solana? Usually what we do is we create a smart contract, usually as Bjorn said in the last talk, you can create a smart contract using Rust, using C, using Python, soon using TypeScript. After that, you have to deploy, and then we come with the front-end interaction. I don't want to scare you with the smart contract development, so today we're going to just talk about front-end interaction and how you can actually code something that is super usable just with TypeScript. So before starting to go into the code, if you want to play around a little bit with Solana, your best bet is to just start with the CLI. The CLI is super, super usable. It's very, very easy to use. And you can just learn a little bit how things and like how token interaction works, how Solana interaction works, Lamports, and pretty much whatever you need. So your best bet if you're new to Solana is to just install the CLI and just start playing around with it. The slides will be available after the presentation, but yeah, if you follow the link that is down below, you just need to run into your terminal the command that it's like the first command on the website. And once you run it, pretty much you just install or like the CLI, and you can start playing with it. So what you can do with the CLI, you can set a cluster because, as Bjorn said before, on Solana we have different clusters. So you can operate on mainnet, you can operate on devnet, you can operate on localnet, you can operate on testnet. Naturally, when we are creating something production ready, we need to be ready to start using it on mainnet because mainnet is where the economic security comes from, and like pretty much it's where you should be. But naturally, it might be very, very expensive to start testing directly on mainnet. That's why we actually usually test stuff on devnet or localnet. Pretty much localnet is like we spin up our own validator on our PC and we start testing program very, very fast without pretty much, even without an internet connection. So you can set your cluster, you can create new keepers, so keeper is equal to wallet. Pay attention to never share your keeper because people can just take your money. You can set different keeper, you can get an airdrop. Naturally, it will be very, very fun if we could get like a sole mainnet airdrop, but yeah, that doesn't work. We can get an airdrop only on localnet, on testnet, or on devnet. So pretty much, if we want to test out some program, we still need Lamports. So by using the airdrop function, we can just get the Solana that we need to start testing. Or in that, check balance and transfer sol. I know it's a boring list, but you'll see why I actually mention it later on down the presentation. So before moving up with how we want to code, it's something nice. It's to understand how we should set up our environment to be suitable on how to start coding on Solana. Naturally, it's just a suggestion. You don't have to use Visual Code Studio because there is Cursor, there is other different IDE, but my favorite is Visual Code Studio. I use it a lot. I like it because of the extension that there are. I like it because for me, it's super intuitive, it's super fast. So if you are not sure what to use, just download Visual Code Studio, and it will be super, super easy to start working on it. Other than that, these are some of the extensions that I use. So I use ErrorLens. So instead of having just a squiggly line and having to over the squiggly line and see what's the error, ErrorLens actually tells you near the line where the error is. Then you have GitHub Copilot, who doesn't know Copilot, but pretty much it's, you'll see once I start live coding, but it's really, really good because it pretty much tells you what you're thinking before you're actually writing. So if you can spare some money, GitHub Copilot will streamline your development and make it very, very fast. Other than that, GitLens, if you're using GitHub much, you should probably use GitLens. It helps you keep track of all the different commits. It helps you keep track of the comments and pretty much everything that is related to Git. Yes, and here there is the link to download Visual Code Studio. So after the presentation, you'll just get a slide. You can click on it, and it will take you to where to install it. So I actually made a mistake because I don't want to talk about the native programs. I want to talk about the system program. But since it's written on the slide, let's just talk a little bit about native programs and smart contracts. So in Solana, there are two different types of programs. Before, Björn told us that if an account is executable, it's actually a program. But there are two different types of programs on Solana. The first of all is a native program, and the other one is normal program. So the normal program are the program that you deploy. So we talked about this before with Björn. But native programs are actually the baseline of how Solana works. So they are not actually deployed by anyone, and they cannot actually get upgraded if the validator community doesn't want to. So it's embedded into the validator, and to update it, to change it, and to pretty much do anything else, you need to update the version of Solana. And to update the version of Solana, you need to reach 70% of the cluster. So pretty much it's a shared decision between all the active validator on Solana to update it, to change it, to pretty much do anything else. So I wanted to talk about the system program that is one of the native programs. So the system program, what it does, pretty much it helps you create account, it helps you transfer SOL. So pretty much all the baseline operation that you want to do on Solana. As we said before, to actually save some state and actually to create something, to create an account on Solana, you actually have to pay rent. So the payment of rent and everything else is managed by the system program. You're going to see in the slide, and I think it's good for you to know. When we talk about transfer of Solana, when we talk about Solana in general as the token, we never talk about Solana, but we always talk about LAMP ports. LAMP ports is 1 millionth of Solana. So if, for example, I want to transfer 1 SOL, I will not do transfer 1, but I will do transfer 1 million, because our instruction actually expect us to think about Solana in LAMP ports. This is actually quite cool because, first of all, rent is super, super cheap, and transaction fee is super, super cheap. So we need something that is very, very small to pay those stuff. And if we start paying 1 Solana for every transaction, it might not work very, very, very well. So we're going to see 2 packages today, because I'm not going to just talk about the system program. I'm going to talk about the token program too. So the first package that we're going to see is the Solana Web3.js. It's pretty much the entry point of everything Solana related. Inside of Solana Web3.js, there is the system program too. Naturally, I will not just talk about the system program in this first part of the workshop, because as much as the system program is very, very important, we need something before actually interacting with the system program to be able to use Solana inside TypeScript. So installation, you can use package manager. I usually use npm. You can use yarn. You can use whatever you want. So just do npm install Solana Web3.js inside of your the folder where your project is, and you can just start using it. So before I did I said all the action that you can do with the CLI, because it's pretty much all the action that you can then do inside the Solana Web3.js. So even here, we have to set a cluster. So when we set up our program, or like when we set up our script, when we set up everything that is Solana related, we always need to tell the chain where do we want to save this data. If it's on mainnet, if it's on devnet, if it's on localnet, if it's wherever we want. So we always need to start with setting a cluster. Then we always need to create keeper. Naturally, we're going to see today that we can create keeper or use already available keeper. So we don't have to create a new keeper every time we want to interact. And if it's like something user facing, we will not even use what I'm teaching you guys today, but we will need to use a wallet adapter. Pretty much wallet adapter do whatever we're going to see later. It's going to fetch your key that you have into your browser without exposing the key pair, and it's going to use that to sign your transactions. But yeah, we didn't have enough time, so we're not going to see that today. But there are countless of tutorial on internet for that. So other than that, we can even there have an airdrop, because we might need Sol to perform some action. We can check the balance, create transaction, and transfer Sol. So when we go inside of the live coding, these 6 will be the steps, or like the action that we will perform inside of our script. So stay tuned for the live coding part. Cool. So other than this, I'm not going to use it in today's code, but it's important to know that at the moment, they're not available inside directly into the Web3.js developer package, but there are some helpers that makes your life very, very easy on some stuff. So for example, if we want to create multiple keeper, right now, we just need to say account A, keeper generate, account B, keeper generate, account C, keeper generate. What we can do is inside of this package that is Solana developer helpers, we can find a way, for example, to create multiple keeper with just a single instruction. And there are countless of other helpers that can streamline your development. So if you're actually serious about it, just go read the README of the helper of this repo that you can find on Solana developer helpers, and just learn about all these super helpful helpers that will streamline your development. So before going into the live coding session, I'm just gonna talk about the SPL. Yeah, that's another mistake. I wanted to say SPL token program, because SPL, it doesn't actually mean anything, because SPL is the name for Solana program library. That is pretty much all the native token that you have on Solana. So we're going to talk about the token program. So we said before that the native program does actually have all the basic information about like LAMP ports, creating account, rent, and everything else. If we want to start thinking about tokens, we have to go inside of the token program. So everything that is token related is going to be found inside of this program. So we have 3 very, very important components inside of the token program. And we're going to talk a little bit about each and every one of them in the specific. But just to let you know, a mint is what we refer commonly as a token. So for example, bonk is a mint. And the mint is actually the public address associated with bonk. So for example, if we want to trade bonk, we will need to fetch the public key of that token and then telling the program that we want to actually transfer that token. So mint equal token. But if we think about how we can actually think about like ownership of those tokens, it doesn't come up like a very easy way to do so, because bonk has millions of holders. So can we like have all the holders inside of one account? No, it's not possible. And so there is a super practical question. It's like the account will be just too large and will be just a mess to check ownership if everything was inside of the Mint account. There is a more technical question that is, Solana works on, like every time you use an account, you have to lock that account to make it mutable, because you need to change something inside of that account, and you can not have concurrent locks. So pretty much you could have just, if we have just one account with all the ownership, we could transfer that token only one time in each block. So yeah, not that feasible. That's why we actually have token accounts. So token accounts can be both generated from scratch. So you pretty much it's just saying, yeah, I generate a keeper and said, yeah, this is going to be a token account. I create a token account inside of it. Or it can actually, like, to make it easier for wallet and for pretty much everybody that wants to check if the account is really a token account, we can use the associated token program. So the associated token program is an external program. It's still a native program that pretty much helps you make sure that that token program is derived from both the mint and the owner. So Bjorn before talked about PDA and it explained it very, very well. And it's a deterministic way that makes it easier for people to just use accounts. So an associated token program does the same, and it derives, it always derives that token program based inside of the seeds based on the owner of that token account and based off the mint. So we just don't have to, for example, call an RPC call and say, yeah, please, can you find me the token account of this guy? No, we don't have to do that because we always know that it's deterministically. So if an account exists, it will be, if a token account exists, it will be found at this deterministic seed. So it makes it so much better, so much easier, and pretty much it's like a godsend for everybody that is trying to use token. But yeah, you can even just create a token account, but yeah, that's not the way that you should do it. After all, it's the token program. So before, I talked about how the token program is the way we interact with token on Solana, but the reality is that on Solana, at this moment, there are two different token programs. The first one is the normal token program that we're going to use today, and it's pretty much all the basic infrastructure for token. But Solana, while it was trying to find something more innovative, something not better, but something different, actually created the Token 2022 program. That is pretty much the same as the token, but on superpower. So what you can do with Token 2022 is create this different type of behavior for directly for the token directly inside of the program without having to create any smart contract, anything else. That are called extension. So we have, for example, a token extension that is called transfer hook. So every time I transfer some token, I actually execute that hook and execute the logic inside of that hook. So I can pretty much say, yeah, every time you transfer a token, I want to save that data inside of an account. So I can have like the true volume of that token, or countless of other stuff with the transfer hook. Or we can have like the permanent delegates, something that it's sometimes thought about like something against the basic of blockchain. But yeah, if we want to have like a TradFi guy coming inside of Solana, we might need some legislation around tokens. And so with the permanent delegate, you actually, the permanent delegator, you can call that, it's actually the possibility of always freeze token or transfer it out, even if it's not inside of their token account. So we have one person that is pretty much has the power to do whatever they want with your token too. Naturally, it's a risk, because if it's for a meme coin, yeah, probably you don't want to some maybe ruggers or like some person that is not very trustworthy to have like the authority over your tokens. But if we're talking about like a serious business, for example, a stable coin, to be compliant, they have to have permanent delegate. And that's why, for example, PayPal USDC that has been released like, I think 6 months ago or 3 months ago, actually uses token 2022 and uses the permanent delegate just to be compliant. But yeah, don't worry about that. It's something that it's a little bit more advanced, but to be honest, you can do whatever you want with normal token anyway. So we talked about the Mint account that pretty much has all the data for tokens. In fact, if we see what's inside, the fields that are inside of the Mint account, we see that we have a Mint authority. So who has the possibility of minting new token? We have the supply. So for example, how many tokens have been minted from when the account was created? The decimals, this is because the same as Lamports, we don't always want to trade token by the number, but maybe we want to trade like half a token, a quarter of a token, or 0.0001 token. So the way that it's done, it's that it's like we save the decimal because we don't want to save in a field that maybe tells us what's the balance of your token account as like a fractionalized number. So pretty much it's like the decimal, we can call that like the precision of the token. So if like it has 6 decimal, I can like the smallest part of that token is 0.000001 token. So 501 token. 501. Other than that, well, is initialized is just a flag, and then we have the freeze authority. So is initialized is just a flag because with normal token you cannot actually close the mint. So it will always be there. And the freeze authority is a field that will pretty much will tell you if that keeper can freeze your token. So for example, if I want to talk about like, I don't know, the staking of those tokens, I will need somebody and do it in a non-custodial way. I will need somebody to freeze those tokens inside of my token account. So, and the only person that can do that is the freeze authority. But yeah, usually for meme coins and for everything else, it's always set to none because we don't actually want anybody to have the possibility of freezing our token. The token account, since we always talk about like ownership, it has the mint and the owner, naturally, because we want to know about what's the mint that like we have ownership of and who's the owner of those mint. Then the amount, so how many tokens do you have? And the delegate, it's the possibility of pretty much I can delegate somebody else to act on my token account. So it's always set to none by default, and we have to decide to give the delegate to somebody. So for example, if we want somebody else to trade our token, instead of like just giving them the token, we can just give them the authority over those token accounts as a delegate, and they can do whatever they want. So what we're going to see today during the live coding session will be how to initialize a mint, how to initialize a token account, how to mint some token inside of the token account, and how to transfer those tokens. So one cool thing that I just need to say before we start actually live coding is when we think about transfer, when we think about minting token, pretty much every time when we think about the token program, we completely have to scratch the normal wallet. We always need to think about tokens inside of the token account. So when we're going to mint some token, we're not going to mint it inside of the wallet, but we're going to mint it inside of the token account. So just something to keep in mind while we go through the code. So yes, hopefully I didn't bore you too much. I just did 25 minutes, actually a pretty good time. And yeah, I think we can just start live coding. So I prepared some script. I'm gonna then save it on GitHub. You will have both a template and a full example. So you can redo what we're going to do today by yourself without any help. And if you need help, you can double check inside of the complete script. So yeah. Can you guys hear me okay if I just don't use the microphone? Cool. Just because it's a little bit of a pain to just go with the microphone and code. Cool. So. Is the screen bigger? Like, is the screen big enough? Can you guys here see from the back too, if you are interested in?
Move more to the front, guys. This is very cold. I can't really read it, so whoever needs it, go more to the front.
Yeah, I'll just make it a little bit bigger. If maybe this is too big, I cannot code. Yeah. Oh, I didn't upload it yet. I will. I forgot to do it. I will upload it after the lesson. Cool. So, as I said before, you have both a full example and example. You will have an example template. Other than that, so first of all, before you actually can start coding, you will need to initialize. Like you will need, for example, initialize the package as a TypeScript TypeScript folder. So I will add into the README like the basic setup. So you can just copy and paste the basic setup. So not for this example, because when you will find it on GitHub, will already be with like everything that you need, because I already initialized the folder. But if you want to create a new package, you will need to, before initialize it as a folder that uses TypeScript and that accept certain type of package. So I will just add that into the README so you guys have it. Cool. So I'll say let's start by the system program example. It's not, I forgot to upload it before. So I will upload it just after the lesson. Sorry about that. If you guys like cannot see and want to see it, there is even like a live streaming. You can just join the live stream and watch it there. Cool. So the first step of everything that we need to do with the system program, we'll need to generate a new keeper. By generating a new keeper, I mean generating a new wallet that we can use to interact with the chain. So it's super, super easy. Just gonna uncomment this part. It's super, super easy. To generate a new keeper, we're gonna just take the keeper type from Solana Web3.js. We're gonna do just keeper.generate. Naturally, we're not just talking about a public key. We're talking about keeper. So inside of this keeper, there are two different fields. One is the public key. So pretty much your wallet. So how you can see that wallet on chain. So if I need to send some money to somebody, I will never ask their secret key, but I will always ask their public key. The secret key is something that you want to keep super, super secret, because if somebody has the secret key, they can do whatever they want with your account. So since this is just an example and I'm just creating a keeper from scratch, the way that I do it is like we create a new keeper and I console log the public key, so you can grab it to do whatever you want, and I console log the secret key too. But this is just because we're gonna see once I finished up with the script that I'm gonna take those value and put inside of a JSON account, so then we can use that JSON account instead of creating a new keeper for the second example. But yeah, I added a disclaimer at the start. This is dangerous. You don't have to do that. So please be safe with your secret key. After that, we need to connect to a cluster. So for the sake of this example, I usually like better to just use the local net, because on local net you don't have any restriction. On DevNet, after you request 2, 3, 4 airdrop, it will start bothering you and says, yeah, you don't want to spam the chain. So usually I like better to just use local net. But yeah, for the sake of this example, and just because it's better, because I will need to teach you guys how to set up your local validator, I'm just going to use the DevNet. So to create a new connection to the blockchain, we need to use the connection type from Web3.js and start new connection. And what is going to ask after that is going to, like the address of this new connection that we want. So I think it's I think so. It's DevNet. Let me double check. Yeah, it's not. Nice. So the cluster of the DevNet cluster is actually api.devnet.solana.com. And after that, we can set up a commitment, or we can leave it blank. So this confirm that I have here, I could just delete it, and it will not throw an error. But if we actually want, for example, confirmation is the fact that we want to continue with our script only when we get a confirmation by the chain that that transaction actually hit the chain. So if we want to always have the waiting for the transaction to hit the chain, we need to add a commitment as confirmed. So after that, we're just going to request an airdrop because we need some Solana to perform some action. So the way we do that is we're going to go inside of the connection type, and inside of the connection type, there is the possibility, for example, to get a balance. We're going to see that later. Like get the account, pretty much everything that is based on a chain interaction, we can find inside, and that it's not a specific instruction, for example, from the system program, we can get it from the connection type. So connection.get request airdrop. We can see that request airdrop actually want us a public key. So who is going to receive the airdrop and the amount that we want to send. So in this occasion, and naturally we want to pass in the public key. So public key. And after that, the amount. So as I said before, if I just leave it with a 2, it will just send 0.000002 Solana. But there is actually a helper directly inside of Web3.js that makes it super, super easy to actually transfer Sol instead of Lamports. So if we multiply 2 by Lamports per Sol, we see that Lamports per Sol is just a million. It's just a number. So we can, to make sure that we're always transferring X amount of Solana, we can just put the number and multiply by the Lamports per Sol constant. So yeah, this will give us back wait, I forgot the wait. This will give us back a transaction signature that we can then, for example, paste it inside of the Explorer, the Solana Explorer, like the Solana Explorer or like Solana FM, and it will give us it will tell us what actually happened during the transaction. So yeah, for the sake of this example, I just pasted in here. You can just click on the link, and it will go inside of the Explorer and will show you whatever you perform. So as I said before, now we want to check the balance to see if actually the airdrop worked. So as I said before, if every interaction with a chain that doesn't require a specific instruction, it will be inside of the connection type. So connection dot balance, and the get balance will just ask us for a public key of what we want to find. So yeah, keeper.public key. So yeah, we're gonna see later that it will give us back a balance. Now, what we want to perform is a transfer from from public key that we just created and that we airdrop something to a completely blank keeper. So first of all, let's create a new keeper. And since we don't need it to sign, we can just already say, yeah, give me the public key. Forgot to add a console log, just the public key of the new keeper. So what's going to happen later will be new transaction. So by doing this, we tell the code that we are actually trying to create a new transaction, and after that we're gonna just do transaction. It's not needed. We could have just do new transaction.add, but I like it to make it a little bit more cleaner. We're gonna add the single instruction that we want inside of a transaction. Because one cool thing about Solana is that not every instruction equals a transaction. You can have multiple instructions. You can perform multiple atomic compliant instruction. So for example, if I want to make sure that I transfer out some SOL to get some other token back, I don't need to transfer out the SOL and like wait for the other guy to transfer back the token, because it will not be safe. So we can add like two different instructions, one that tells you, yeah, transfer SOL from point A to point B, and the other one that transfer token from point B to point A, completing the same transaction and completely atomically. So if one of the two instruction fails, the whole transaction failed.
Question to this. I say, understand it right. If you want, you can have a transaction with two addresses. Right? A transaction from A to B to C.
You could have everything you want. It's like you could add as many instructions as you want till you reach the transaction limit that is 1024 bytes. So pretty much like I could like now we're gonna see that, for example, I call the system program.transfer, and this will actually transfer out some lamports, because we're still talking about the system program, not the token program. And the params of the thing are going to be transfer param. They're going to be the from pub key, the pub key, and the lamports amount. So the from is going to be the keeper, public key. Oh, actually, maybe the from needs to be a signer. No, okay, no. Okay, yeah, but I don't need this. Interesting. Oh, yeah, okay, never mind. 2 will need to be the 2, and the lamports, I'm gonna send out 1 lamport. Cool. Why from doesn't? Oh, it's the from. Oh, it's from pub key actually. Okay. So what this instruction does is going to transfer 1 SOL, so the amount is there, from the keeper that we just generate to the 2 keeper to the 2 public key that we just generate. Naturally, so coming back to what I was saying before, like for example, I could spam this, and now in theory, what it will happen is that 3 SOL will be transferred out. But if you remember before, we actually only airdropped 2 Solana. So what it actually happened is we're not actually going to send any Solana, because it will fail at the 3rd instruction and says, hey, yeah, you have 0 balance. You cannot transfer more SOL. So instead of just like still going through with this 2 instruction, since we want to maintain atomicity, well, the 3rd instruction will fail the whole transaction. Cool. So once we add the transaction, what it will ask for is going to be a block hash. So get latest block hash. Cool. So what, like as Bjorn was saying before, to make sure that the transaction is always up to date, we have to commit a recent block hash to it. Cool. Interesting what I'm missing there. Oh, block hash naturally. Because this actually doesn't give us just the block hash. Cool. And then we have a fee payer. So the fee payer is going to be who pays for the transaction. So since we don't have any priority fees on it, it's just going to be 0.0005 SOL, or like I think 500 lamports. So yeah, we're gonna just say that the keeper is going to pay for the transaction. So one thing is now just doing this, like we saw before that just by setting up those helper, like the the request airdrop, the get balance, and everything else. It will give us back the already a signature, because the transaction is always automatically performed once we call that function. When we create a transaction from scratch, that doesn't happen. So we need to take the transaction that we just created and say you need to send and confirm transaction. So as params, inside of it, we're gonna pass in the connection, so where we want to post that transaction, the transaction data, and most importantly, the signer. This is because, so for sure, one of the signers will always be the fee payer. And second of all, in this occasion, if you think about it, it's like here we're just passing in the public key. The public key, everybody can have just the public key. So it's like if I could perform a transfer by just knowing your public key, it will not be safe, because if you share your public key with me, for example, for a transaction, I could just drain your wallet. So in this occasion, during the transfer, the from pub key always needs to be a signer inside of that transaction too, because we need to make sure that you're actually the guy that owns that wallet. And yeah, the same goes for the fee payer. I could set up like a very, very high fee, and I could just drain your wallet like this. So the fee payer needs to sign too, because we need to make sure that we actually know who is the, like that you actually own that wallet. Cool. So I already set up into the package.json. If you see here, I already set up like a script that says that uses TS node to run the script. So but just do yarn system program example. Interesting. So, okay, seems like while I was testing. Oh, wait, okay, I think I know why. So the transaction got posted too fast, so I just need to. So it didn't, I think so. Yeah, see, what I was saying before, it's the second time I request an airdrop, and the server is already saying, yeah, you requested too many airdrop, I don't want to send you another one. So that's why usually it's better to just use the local host. But let's see if I can actually. So that failed, so it means that one time it worked. Yeah, yeah, as I was saying before. So, let me actually switch up to local network. So I just tested the script before, and now it's saying that I requested too many airdrop like an hour ago, so I cannot test it again. And so there is no soul inside of that. So, yeah. What? Yeah, the problem is, wait, I think there is a. Yeah. Wait, 1 second. It's gonna. I just doxed myself, but it's okay. Okay. If you can send some soul there, Lucas, I will greatly appreciate you. Yes. Okay, this will use it later, so I will just explain it later. Nice, thank you. Yeah. Okay. Interesting. Yeah, okay. I don't know why the script doesn't work, but yeah, it's correct. I think I made a mistake, but yeah. So, since we are just have 50 minutes, I'll just explain the SPL token program, then come back to this and like make it work for when you guys have the repo. Not sure what's. Cool. So sorry about that. That's the beautiful thing about live streaming. So we start with getting, so as you see before, after I generate a new keeper, I actually took that values that I had, and I pasted it inside of my wallet.json file. So what this does is, is my secret key, so everybody can just steal my wallet. And but the way, instead of like always generating a new keeper, we could just like read a keeper from a secret key that we stored. So I import the JSON file from the wallet.json, and then I read that keeper from the secret key. So we're using a uint array and passing in like the wallet number as a uint array, and using the keeper from secret key instead of keeper.generate. After that, we connect to DevNet, and yeah. So first of all, we need to create a new token mint. So to make sure that we actually have some tokens, we need to create a mint. So we're gonna use. So first of all, I already imported the SPL token package because we're gonna use that too, and then we can use the create mint. So first of all, we need to pass in the connection. Then we need to pass the payer. So in this occasion, will still be the keeper. Then we need to pass in the mint authorities. So who's going to be able to mint more token. And then we can decide to add a freeze authority or initialize it already with no freeze authority. For this example, I will initialize the mint with no freeze authority. After that, we select how many decimal we want to pass in. So I usually use 6, and you're good to go to start with creating the mint.
So are they necessary params? Or?
Yeah, these are all necessary params. There is no optional params in this part of the thing. Like the only optional params is the freeze authority that you can pass in as null. Naturally, you cannot pass the mint authority as null from default. Like you will probably want to change that authority and set it to null after you mint all the necessary token to make sure that you cannot just inflate your mint forever. But like when we create a mint, we cannot actually do that because there are no actually token mint. So it's like you will just create a mint account that does nothing. In fact, what is in fact, to showcase this, we can get like the mint account. So using the getMint function, telling in the connection and who is the public key where the mint account resides. And inside of the mint info account, we can have all the params that I showed you before. So for example, the supply, who's the freeze authority, if it has some, what's the mint authority, if it has some, and everything else. So by doing this, the supply will just say 0. And because we actually didn't mint any token yet. After that, as I said before, if we want to mint some token, we cannot mint it directly inside of a wallet. We need to mint inside of a token account. So we need to create a token account. So one cool thing is that Solana, instead of just having a function that tells you create a token account, as a function that it uses get or create token account. And this is very, very important because it might happen that you already have a token account. So instead of like fetching the token account, seeing if the token account actually exists, this is all like, and doing like setting up all this logic inside of every function that I use when I need to create a token account. Solana does this for us under the hood inside of these instructions. So if the account doesn't exist, it will create a token account. If the account does exist, it will just get it for us. So we need the connection, the payer, that is going to be the keeper, the mint, the mint public key. Now we need the owner of the associated token account, going to be the keeper in this occasion. And then we need, and those are like or optional stuff that we might not need. Cool. So one thing to pay attention is that differently between, like, for example, when we do the create mint, will give us back a pub key, and that pub key will be the mint pub key. So since this is get or create associated token account, it will pretty much will do both the create mint and get mint. So the response that we actually have is a response that is similar to the get mint, more to the get mint function than the create mint function. So we'll actually get back the token account data. So this is not a pub key, but it's a type of account that is a type of token account. And so if we want to access the pub key, we need to say token account dot address. Cool. So finally, we can mint some token. So connection, then we need the payer, it's always the keeper. Then we need the mint pub key. Then we need the destination, that is going to be the token account address. Then we'll need probably this is the mint authority I think this is null. Okay, that was. So here we need the mint authority. Naturally, the mint authority can be a multi-sig too. So if like we want the way that a multi-sig work is that it needs the signature of multiple wallet before using the like actuating on the instruction. So if we actually gave the mint authority to a multi-sig, because we need it to be safe, here we're gonna pass in just the public key of the multi-sig, and then we're gonna pass in here the keeper of the different signer of the multi-sig. But since we're not actually using a multi-sig, we just need to pass in the payer here and just null there, I think. Wait. Oh no, okay, yeah, this is just the number. So yeah, for example, in this occasion, we know that the decimal is 6. So if we want to mint one token, we're gonna need to actually mint 1,000,000 token. So one cool thing to, like, you could use like the delimiter like this, so it's easier to read. Or what you can even do is, like, if I want to mint one token, I can say 1E6, and it will mint actually 1,000,000 token. So it's actually pretty easy to if you do it this way. So now we could get, like, for example, a mint info updated, because if we just log the mint info.supply, it will still say 0, because it's the data that we saved when we minted before the mint. If we actually want to update that mint, we just need to do it again. And this time around, we'll see that we actually minted 1,000,000 token, that it's actually 1. After this, we can finally transfer out those tokens to another wallet. So we can do keeper that generate the public key as before, but naturally, we need to create the token account for the receiver too. So one cool thing is, you don't need to be the owner of the token account doesn't need to sign on the creation of that said token account. because if I want to transfer out if I want to transfer U token, you probably don't want to wait for the person to create a token account so they can receive. So anybody can create token account for anybody, and it's completely safe because nothing happened with a token account. So us as the from pub key, we're gonna create the 2 token account, and at the end we're gonna transfer out the token. Connection. The payer of the transaction, the source, that is going to be the token account. Naturally, the source is not the wallet, but the token account. Then we have the destination token account. Then we have the authority over the source token account. This is, and then the amount of token we want to transfer out. So yeah, this is it. So I'll just add the script on GitHub. I will review the system program. I think it's just because I already sent too many requests, too many airdrop, and that's why it wasn't working. But yeah, we'll review that, and we'll share the code at the end of the day with the recording and and the slides. So hopefully you'll learn something today, and thank you for participating. Oh yeah, sorry. Right. Question, anybody?
The thing is, I'm just starting to programming now on blockchain and stuff, and that's the what I start with. And I want to ask you, because you showed us a way without Rust. Like it's you have like a package, a module created with documentation where I can code on blockchain without Rust and use TypeScript framework with your module. And I want to ask you, what do you recommend to start from when you start from scratch? Would you start already with frameworks and don't start from the beginning with Rust and get how everything is working? Or would you say start with Rust, learn everything dry Rust, and then use frameworks and modules?
I think so. One cool thing about Solana is that you can give it. To actually code the smart contract, even if it requires Rust, it actually requires Anchor. You could code a smart contract in native Rust, and this is like super advanced. But once you start learning how smart contract development work, you actually might need to you could use just Anchor. Anchor is like a very, very simplified version of Solana, and it still runs on Rust, so you still need to learn a tad bit of Rust to get started, but you don't actually need to learn and know everything about Rust, because you can just learn Anchor instead. Then it's easier because pretty much like all the difficulty of Rust get abstracted away with those frameworks. So if you want to start learning how to develop a smart contract, you can just start with Anchor without having to learn Rust before. No problem. Anybody else have any question? Yeah. Grazie.
For who not is familiar with coding, how AI can help and AI can build something, if you can tell something about it, thank you very much.
Yeah, for sure. So, like 6 months ago, 1 year ago, coding like we're using ChatGPT wasn't very great because so on Solana there are a lot of open source programs, but not enough to scrape like all the data. So before it was kind of difficult. Lately it's been improved very much. So for example, Copilot pretty much gives you always the right answer, and ChatGPT knows enough to solve your errors, pretty much every errors, and even like code something from scratch. I never tried to just like as non-technical to just code a Solana application, but I believe you actually can. Anybody has any other question?
Why are you so amazing, Leo?
Thank you. Yes. Yes, I'll send the code into our Solana Germany group with like the recording and everything else. But yeah, thank you guys.